So columns questions. So this is about now. A short column is given. Short column is given. Short column means there is no buckling. Now you have to find out the neutral of the short column shown in figure. And this column is subjected to eccentric axial compressive load. Eccentric axial load is how much? 100 kilonewton. Eccentricity is 10. Now the rectangular cross section. Now you have to find out the neutral axis. But then how to locate the neutral axis? Neutral axis is the axis where resultant normal stress is 0. Resultant normal stress 0. Every eccentric axial load equal to one axial load and one bending moment. Then on the cross section you are getting both axial and bending stress. So the neutral axis resultant of axial and bending stress should be 0. So how to do this question now? At the neutral axis, resultant of axial and bending stress 0 means axial and bending stress should be equal and unlike. So directly equate the axial stress and bending stress, you will get the answer now. So here some data is missing here. So here this data is going to be it is 25 mm. The printing mistake, data is missing now. Now how to mark the axis here? Now how to mark the axis? This is for front view and top view. Which axis is common? X is common. So this will become as XX. Now which is the polar axis? Polar axis will coincide with the longitude. This will be the what now? Polar axis. Polar axis always coincides with the longitude axis. But here polar axis coincides with the centroid. This is Z. Now this is Y. Y is perpendicular plane of the board. This inclined line is the perpendicular plane of the board. So VCA will be the Y. Y. Now this load is equal to how many loads? Now one axial load as well as one bending moment. So directly where the stress is maximum, this load is near to right side. So this line will be the right side surface. This load is what now? Eccentric axial load. This load is representing eccentric axial compressive load, EACL, and this is eccentricity. 10 mm is the eccentricity. EACL means eccentric axial compressive load. Now this line of action of the load is near to right side. Therefore, right side the stress should be maximum. Right side the stress should be maximum. Now this is a compressive load or tensile load. So axial stress also going to be compressive. Since here stress should be maximum because load is near to right side. Since axial stress compressive, why axial stress compressive? Because this is a compressive load. But I need the maximum stress means automatically bending stress also going to be compressive. So this side you are getting a completely compressive, you will get it. Right side you are getting completely compressive. Now left side what you are going to get it now. resultant stress on the left hand side. The stress should be, what change you are going to get it now? On either side bending stress are what now? Unlike in nature. Right side I am getting compressive, means left side you are going to get a tensile. So here the stress will be minus sigma A minus sigma A and plus sigma B max. So right side is completely compressive. Right side is completely compressive. But left hand side maybe a positive, maybe a negative, maybe zero will be there now. So that can be decided by when you calculate the what now. If the bending stress greater than axial stress means a tensile stress. If the bending stress less than axial stress means compressive. If both are equal, it is going to be zero. But in the question, it didn't ask about the maximum stress. Directly, sometimes they are asking the maximum stress. Maximum stress will be right side, axial and bending stress. But in the question, is asking neutral axis. At the neutral axis, resultant stress will be zero. Which side it will be zero now? Here completely you are getting compressive. This is a compressive. Overall, this value is going to be compressive. And this side maybe a tensile, maybe a compressive, maybe zero. So the stress may become zero on which side? Now, left side is going to become zero. Because right side you are getting completely on the compressive. Now which one the neutral axis here now? Which one the neutral axis? YY will be the neutral axis. This will form a couple in which plane? Now vertical plane. For vertical plane, which axis perpendicular? Y. This is what now? What this finger represent? The plane of the couple. This is in plane of this digital board. That is what a vertical plane. For this plane, which axis perpendicular? Y. So this couple is acting about YY. So YY will be the neutral axis. So YY will be the what now? About which the bending couple is acting. So when bending couple is acting alone, YY will be the neutral axis. When bending couple is acting alone, YY will be the neutral axis. But here both are acting, axial load and bendment both are acting. So we don't know where the neutral axis. So section modulus should be considered about YY. Bending equation valid, pure bending. So when bending couple is acting alone, so this will be the neutral axis. How to identify this neutral axis now? This couple is in vertical plane. For vertical plane, which axis perpendicular? Z. This is X, Z, and this is Y. So the couple is acting about YY. Therefore, section modulus should be taken about YY. So this is one method. First, identify the plane of the couple. Couple is in vertical plane. For vertical plane, YY is perpendicular. Therefore, this couple is nothing but a CY. Therefore, section modulus should be taken about YY when bending couple is acting alone. Otherwise, what the other method now? Extend this line of action of the load. Extend this line of action of the load into the top view or plane of cross section. If I extend this line of action of the load, it will intersect the XX or YY. If I extend this line of action of the load, it will intersect the XX. Means the line of action of the load is lying on XX. Then couple will be about YY. So this is another way you can find out now. When the line of action of EACL, when line of action of eccentric axial load lies on HCA, then couple will be about VCA. By chance the line of action of the load is on YY, that is the VCA, then couple will be about HCA. So here compressive load, compressive load means cross. What is the meaning of cross? Cross means about a perpendicular inward. Since the line of action of the load on HCA, this XX HCA, VCA. So blindly you can remember it now. Whenever line of action of eccentric axial load is on one of the centroidal axis, that is XX, then couple will be about other centroidal axis in the plane of cross section. Then section modulus should be taken about YY. Moment of inertia also should be about YY. By chance the line of action of the load on YY, then you have to take the section modulus and moment of inertia about XX. That's all. So then completely this side you are getting compress, you are getting. Left side you are going to get it what now? Maybe a positive, maybe a negative, maybe 0. So what you have to do it now? The where it will become 0 now, on the left hand side it will become 0. This value may be a positive, maybe a negative, maybe 0. Depend upon this value now. So that this will become resultant stress will become 0 on the left hand side. Right hand side completely compressive will be there now. So how to locate it now? At the neutral axis, resultant normal stress. What the resultant stress on left hand side? Minus sigma A. Resultant stress is 0 means what now? Both are going to be equal and unlike in nature. I mean, from this one, what you can conclude it now? Axial stress is equal to bending stress. So equate the axial and bending stress, then you can get it now. For the axial stress equation now, P by A. How to find out the bending stress now? Bending stress at inner fiber is given by My by I, but this distance about now x. So what should I write in the bending stress equation now? Mx upon Iyy. Section modulus moment of inertia should be taken about Yy and this distance about the x. Now you can substitute the data, but the p value is given in the question now. (100 kilonewtons). What the area now? Area of the cross section is 100 into 50. What the bendment value under eccentric axial load? Bendment value is what? A load into eccentricity. Load into eccentricity. What the eccentricity value? No, 10. So this will be equal to load into eccentricity upon x. X only unknown. X value is unknown. So what the load value now? Load value is given in the question is 100 kilonewtons. Eccentricity is 10. X the unknown. What the moment of inertia about Yy? How to write down the moment of inertia now? First 1 by 12 dimension parallel to Yy. What the dimension parallel to Yy? 100 and cube of other dimension. Other dimension is 50. What the dimension parallel to Yy? 100. (1 by 12, 100 into 50 cube). Now do this simplification now. This value you are going to get it as 20. 20.833 mm. But this is possible on which side now? Left side or right side now? Left side. So answer will be what now? Option C, on the left side of Yy. left side of YY. So this is one method. Always remember what now? Every eccentric axial load equal to one axial load and one bending moment. Axial stress and bending stress will get, both can be added. This load is a compressive load. This load is near to right side. Since a compressive right side means here what? This load is near to right side means right side the stress is going to be maximum. Since this is a compressive load minus sigma A. Since I need a maximum means already axial stress a compressive means bending stress also should be compressive. Then automatically on the left side what change you have to make it now? Axial stress nature will remain same, but bending stress on either side will be unlike in nature. Here compressive means a tensile. So completely on the right hand side you are getting compressive. This side you are going to get a compressive. But left hand side stress may be a positive, maybe a negative, maybe zero. But I need the location of what now? Neutral axis. At the neutral axis, resultant stress is zero. Resultant stress zero means axial and bending stress both are going to be equal. So directly what you are doing now? Equate the axial stress and bending stress. Axial stress P by A and bending stress is at inner fiber, bending stress given by My by I. When should I use this now? When should I use the Y? When XX is the neutral axis. But here which one the neutral axis now? YY. Then I have to write down the M into X. But bend moment equal to load into eccentricity. And section modulus should be taken about YY. Moment of inertia and section modulus should be about YY. Already explained now. Since this couple is in what? A vertical plane. Couple is in vertical plane means it will be about YY. Directly that method. Otherwise, extend the line of action of the load into the plane of cross section. If I extend it, it will intersect the XX. Since the line of action of eccentric axial load on XX, couple will be about YY. So I have to take the moment of inertia about YY. How to write down the moment of inertia about YY? 1 by 12. First I have to write down the dimension parallel to the axis 100. Then cube of the other dimension. Then you can get the X value. But the left side or right side means it is going to be a left side. The answer is C. This is one method now. But the other method we can do it now. We can use the similar triangles, resultant stress variation. This is one method by whenever you ask the neutral. This type of question never is there. Only in one of the DRDO paper this question is given. So whenever you ask the neutral axis, when both the loads are acting simultaneously, directly equate the axial and bending stress. But when bending moment is acting alone, which one the neutral axis now? YY. When both are acting simultaneously, neutral axis never coincide with YY. It will coincide either on the left side or right side. Here you are getting on the left side at a distance of 20.83 mm on the left side. What the other method now? We can use the resultant stress variation. So first you find out the axial stress. Area is check it, you are going to get it. This is 20 megapascals. I am taking the second method, the 20 megapascal. Next, you have to find out the maximum bending stress. Bending moment is nothing but the load into eccentricity upon section modulus about which axis now? ZYY. Now you can substitute it now. What the load value now? 100. eccentricity is how much is now? Eccentricity is going to be 10. How to write the section modulus now? About yy, 1 by 6. Moment of inertia means 1 by 12. Zyy means 1 by 6, dimension parallel to that axis and square of the other dimension. 1 by 6. What the dimension parallel? 100. And what the square of the other dimension? 50. So simplify this value, you are getting as 24 megapascals. Now, what the stress on the left side? What the stress on the left side? Minus sigma, sorry, right side minus sigma A and minus sigma B max. Left side minus sigma A plus sigma B max. Stress on the right side. It is compressive. Stress on the left side. Stress on the left side will be plus 4. You are going to get it now, plus 4. Means this side I am getting compressive, this side I am getting positive. Then where it will become 0 now? And here what the stress now? At this one bending stress 0. When bend meter acting alone, here bending stress 0. At yy only axial stress will be there. So here to here completely compressive. At yy only axial stress, no bending stress. So here to here completely compressive. But here I am getting positive. So it will become 0 on which side? Now left side. Now what you have to do it? Now draw the resultant stress variation. Is a cross section. What this line? Now cross section. This is on the right hand side. The left hand side. What the stress on the right hand side? This is always axial and bending stresses are perpendicular cross section. What this line now? Cross section. And but left hand side what I am getting now? Positive. This is so compressive stress downward means tensile is upward and it will vary linear. Now this will be the neutral axis. Neutral axis. Now you can use the similar triangle, then you can find out now. But this will be the centroidal axis. What this distance now? 25. We don't know this distance. This is x or y now. This is x. Now this will be 25 minus x. 25 minus x. Now you can use a similar triangle, then you can calculate it now. This is a one triangle. Now this is another triangle. So by using similar triangles, then you can find out now what the base of this triangle. 25 minus x. And what the height of this triangle? 4. What the base of this white color triangle? 25 plus x. Then what the height of this triangle? 44. Now simplify. You will get this value is once again 20 point. Now this distance is 20 point. Now this will be the centroid. So it will becoming 0 at what distance now? 20.83 on the left side. This will be the what now? Centroid. So it is becoming 0 at what distance now? At a distance of 20.833 on the left side of YY. This axis is about the YY. On the left side, you are going to get it now. So answer for this given question will be 20.833. So you can do this question two ways. You can do this question two ways. Either you can use the similar triangle concept, resultant stress variation. Otherwise, you can use the directly what now? Resultant stress 0 means axial and bending stress 0. This will take the less time, but this is better to understanding purpose. So only one concept is required is always every eccentric axial load equal to one axial load and one bending couple. And stress is always maximum on the load is near to right side the stress is maximum. And next one is how to identify the neutral axis now. One method is what to identify the plane of the couple. This is forming a couple in vertical plane. For vertical plane, which axis is perpendicular? This will be y. So y. So moment of inertia section modulus should be taken about y. Otherwise, extend this line of action of the load into plane of cross section. If I extend it, it will intersect the x. Since the line of action of the load is on x, then couple will be about other centroidal axis. Therefore, moment of inertia and section modulus should be considered about y. By chance, the line of action of the load is on y. Then you have to consider the section modulus and moment of inertia should be about x. What is the statement now? Whenever line of action of eccentric axial load on HCA, then couple will act about VCA. Hence, section modulus and moment of inertia should be considered about VCA. If the line of action of EAL means eccentric axial load, lies on VCA, then couple will be about HCA. Then section modulus and moment of inertia should be considered about HCA. That is the method you can use it now. So this is a question. This is only one time is given in the one of the DRDO paper. So we'll come to the